And now it's over to Pete, who gave an awesome talk on Stack tools yesterday, but now he's going to be talking about some Rust implementations of Stack. Over to you, Pete.
Yeah, Daniel, I commend you. That was bold. I love it. Yeah, so my name is Pete Gadomski. I'm a geospatial software engineer for Element 84. I've been working with Stack tools, PyStack, and kind of the Python ecosystem for a while. But as a hobby project over the last couple of months, I've been working on a Rust implementation of the Stack specification. That work? It's available on GitHub. It's open source licensed, all that nice stuff. The current release is 0.0.4. I'd like to get to a 0.1.0 soon enough, but it's a hobby project, so you know how that goes. The motivation is kind of this. A lot of the geo problems that we run into from a software side aren't really geo problems. People at my company say this all the time. I've heard it in other places as well. A lot of it are just software problems. And I find that Stack in particular has a lot of things associated with it that aren't specifically geo, right? So there's a lot of I/O required to read all the links and assets. You know, you might be using it to do database access, things like that. Because it's a tree structure, it obviously lends itself very well to software engineering sort of solutions. And it's just big. There's a lot of Stack things. So if you can be a little bit more efficient, that can be a big win for people. I think Rust is well suited for it. I'm generally not a language purist. I think programming languages are tools for jobs, but I think Rust is a good language for this sort of job. First, because it's focused on performance. It's a compiled language. There's no runtime, no garbage collection, and it really makes you think about memory management and ownership and data layout in a really kind of, in my opinion, understandable way that really encouraged you to write performant code. One of the taglines of Rust is fearless concurrency. The compiler itself helps you make concurrent code, whether that's kind of in a async await sort of environment or in an explicitly threaded one. And so because it's such kind of a first class thing in the language and it doesn't force you into a certain concurrency model, you have a lot of flexibility with if you want to do parallelization with a Rust library. Finally, it's aware that it's kind of a new language, and so it plays really nice with others. It has really strong FFI support. It doesn't ask you to rewrite all your stuff in Rust. It's really made for writing like microservices, and as discussed previously, it integrates well with WebAssembly as well. So a quick overview of the library and what it's what it has right now. So if you wanted to use it, what you would be opting into. First of all, it has just the basic Stack data structures for Rust. It doesn't have any of the other things on the data structures. So one thing I learned from PyStack, PyStack kind of has a lot of the I/O stuff kind of baked into the data structures, and that gets pretty complicated pretty quickly. In the Rust library, we just keep it simple. So if somebody wanted to just use the basic Stack data structures and do something else with it in their Rust library, they could do that without having to worry about I/O stuff at all. I/O is a pretty tricky thing in the Stack ecosystem because you're working with various cloud providers. You know, we see people using FSspec and Python and all these other things to kind of work around this. In Rust, I use traits to basically abstract out the idea of reading. I provide a very simple reader and writer, but if you wanted to write your own that can deal with S3 buckets or that sort of thing, the library is generic over readers, and so you can kind of bring your own I/O to the party and still use the library. Finally, I put a lot of work into that kind of tree stuff because walking trees in Rust is pretty squirrely. At least I've found that when I've been building a lot of stuff for the Planetary computer and things like that. And so there's kind of some ergonomics that I won't go into here around walking tree structures with iterables. Rust is very good at this sort of thing. It has what's called zero cost abstractions, where you can kind of use native iterator interfaces without taking a runtime hit for how they execute. So that's just a quick overview of what the library is. Again, because it's a hobby project right now, I have a pretty, whenever I want to do it, sort of roadmap, but I'd like to start specking out some of the async stuff and maybe making an API client. Of course, if other folks wanted to come to the party, they're more than welcome to. And there are the relevant links, and happy to take questions in Gitter or elsewhere.
Awesome, thanks so much. Super cool to see. Yeah, I love seeing Stack have just representations in more and more and more languages. Yeah, and I think it seems like we're hitting the fun ones like Go and Rust, and yeah, out of just the core Python and Java. Awesome.